When evaluating square roots or other even roots, we can't take the root of a negative number. That's because there's no number that we can multiply 2 times or any even number of times to have a negative sign. We know a negative times a negative equals a positive number, so any number of 2 negative signs would always be a positive. So we can't exactly simplify the square root of -1. We know it's not equal to -1 since -1 times -1 really equals +1. And we also know that the square root of -1 does not equal +1 since 1 times 1 equals 1. There's no value in the real number system that gives us the square root of -1. We'll need something else for this. It turns out that we define it as I, an imaginary number. I allows us to take the square root of negative numbers. For example, if I wanted to take the square root of -4, I would split this radical up into the square root of -1 and the square root of 4. We know that the square root of 4 is simply 2, and the square root of -1 really equals I, our imaginary number. So we get a product of 2i. For the second one, we'll have the square root of 3 times the square root of -1. This number really represents I, so we replace the square root of -1 with I. We leave the product of any factors in front of the radical, so we'll have I times the square root of 3, our final result. And for our last one, we'll have the square root of -1 times the square root of 12. We can simplify the square root of 12 by breaking it up into the square root of 4 times the square root of 3. We know the square root of -1 is really equal to I, so we write that here, and then we take the square root of 4, which is 2. We multiply these two together to get 2i times the square root of 3. In a lot of ways, we treat I just like a variable. We list it after the product of any numerical factors, but before the radical sign. Now that we've seen a couple of cases of simplifying negative radicals with I, let's see if you have the hang of it.